guys, welcome to another video in the series of coding. Today we are going to do the problem which is called paths in matrix whose sum is divisible by k. This is the last problem of today's contest. Let's get started. So we are given a matrix grid and an integer k. We are currently at the position 0, 0 and we want to reach the end of the matrix. We can move only down or right. We have to return the number of paths where the sum of the elements of the path is divisible by k. Let's try to take an example to understand. Suppose this is our matrix. Okay, this is our matrix. I have written the indices in red color. So 0, 0 coordinate corresponds to this cell which has a value of 2 and so on, right? So this is my matrix with the corresponding coordinates. Now in this matrix I can only move down or I can only move right, and I have to start from the first cell and I have to reach the end cell. So I am starting from 0, 0. If I decide to travel down, then I go to 1, 0. If I decide to travel right, then I go to 0, 1. If I go this path, right, from 0, 0 to 1, 0, the sum that I have taken is 2 because I have taken the first cell which has a value of 2, right? If I go down or right, doesn't matter, but if I take the first cell, I get a sum of 2. If I decide to go further down, second time if I decide to go down, then I go to the coordinate 2, 0. Right, I reach the coordinate 2, 0 and I have a sum of 2 plus 3 which is equal to 5. First cell is 2, second cell is 3. So the sum till now is equal to 5. Okay, so and so on, right? If I build this entire recursive flow chart starting from 0, 0 till I reach 2, 3 along all the paths. Okay, how many paths are possible? 10 paths are possible in my matrix which are giving you the starting from the starting to the end. There are 10 paths possible, right? Now the final sum of these paths I have written as such. So there are 10 paths, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and these are the final sums. Okay, now in this sum, in the final sum that I have in the question, it is asked find out the number of paths such that sum mod k is equal to 0. Let's take an example in which k is equal to 3. If k is equal to 3, we are looking for the sum of the paths such that it is a multiple of 3. So notice 15 is a multiple of 3, 12 is a multiple of 3 and so on, right? So I have these paths which are multiples of 3. So my answer is equal to 6 because there are totally 6 such paths. If I take the total sum, that will give me a multiple of 3 or divisible by k, properly divisible by k, right? So now how to solve this problem? So a very simple brute force approach to solve this problem is using recursion. Start from 0, 0, try to travel down, try to travel right. There are only 2 paths and do the same thing for every such path and so on, and reach the end, calculate the final sum, find out if the sum mod k is equal to 0. If it is equal to 0, return that it is a path which is a valid path, right? So let's first of all code the recursive solution. Let's code the brute force approach and then we'll see how to optimize it. Okay, so let's say I have a function. In this function I am going to pass the parameter. First parameter is grid, the second parameter will be k, the third parameter will be 0, 0. I am starting from index 0, 0, so I is equal to 0, j is equal to 0, which denote my indices. And then I have a variable sum. So initially sum is also equal to 0. So I have a sum at each step, and finally if the sum is divisible by k, I should return the number of such possible paths, right? So let me declare this function. It has 5 parameters. First 2 parameters I can just copy from here. Third parameter is I, fourth parameter is j, and last parameter is sum. Now what are the base conditions? Let me write the base conditions. So the first base condition is if ever you reach such a condition, I is negative, j is negative, or I is greater than equal to grid of 0 dot size, or j is greater than equal to grid of 0 dot size, in all these conditions you can just return 0. These are not valid paths, right? The coordinates are not valid. Okay, what is the next base condition? Next base condition is if you reach the end of the matrix. So if I is equal to grid dot size and j is equal to grid of 0 dot size minus 1, here we have to give minus 1. So we have reached the correct end cell. So this is the condition when you reach the last cell of the matrix of the grid, right? If you reach this, you have to check the sum. So first of all, this cell will also get added to the path, and then you can check the sum here. If sum mod k is equal to 0, return 1. You have found a correct path. Okay. Now let's also give this. If this is not happening, right, then you can return 0. So if the sum is divisible by k, then only you are going to return 1, otherwise you are going to return 0 if you reach the end cell. Okay. Otherwise you have to recursively call this function again. So to reach the down cell, to reach the cell below this cell, what you are going to do, you are going to recursively call this function again, increase the value of I. If you are at 0, 0, if you want to go below, you are going to go to 1, 0. So you are going to increase I, and you are going to keep j same, and you are going to keep increase your sum also. So sum will become equal to sum plus grade of ij. Your sum is going to increase at each step. You are going to add the current element, right? This is the condition when you want to go down. Okay, there is a condition when you want to go right also. If you want to go right, what is the condition? I will remain same, j will get added by 1. This is the condition when you want to go right, and above is the condition when you want to go down. There are only two conditions possible. Now let's store the answers in two variables, down and right. Finally, what are you supposed to return? You are supposed to return the number of ways. Okay, one correction before we run this code. This condition here should be I greater than equal to grid dot size, the number of rows, right? And here the spelling should be returned. Okay, now let's run this code and see. If we run this code and see, we are going to get finished, but if we submit this code and see, we should get a time limit exceeded error, because this is a recursive solution and this is not the optimized solution. So even though the solution is correct, it is not optimal according to time. So how do we optimize the solution? Notice something here. If you notice this path and if you notice this path, these two paths are exactly the same. So this gives us a hint that we can optimize it, right? Once you make the calls here, you need not make these recursive calls again if you can just save the answer at this call. Okay. So there are many paths that are overlapping or repeating. Consider this path and this path. They are also exactly same. So once at this step, if we can save the answer, we never need to calculate these answers again, and this is where we can save time and improve the time complexity. How do we do this? So in our function, we have three parameters, I, j and sum. So corresponding to these three parameters, we can make a matrix and we can just store our answer. Okay, so let me take one example. So when we are initially doing the function calls for the first time, then we will calculate the answer. But for later on, if we already see the answer saved here, we will use the stored or the saved answer instead of calculating it again. Okay. For example, let's say we make the call here very first time, right? So we get the answers, right? For example, we know that 15 mod 3 is equal to 0. So we got one path which is a valid or a successful path, which is what we want. So we can save it here. So let me take example. Here we have 2 and the sum is equal to 9 at this step. So corresponding to this, we can save the answer is equal to 1. Similarly, when we backtrack from this, we come at this step, we see I is equal to 2, j is equal to 1, sum is equal to 7. We can save the answer correspondingly 1 here, right? Then again we backtrack, we see 1 and the sum is equal to 5. We can save the answer here equal to 1, right? And so on. We can keep on doing this. First time when we calculate, we will save it in this matrix. So next time when I do the recursive call, right, when I come to this recursive call, I again see the call with the same parameters. I is equal to 1, j is equal to 1 and sum is equal to 5. At this call, I will not go inside this recursive tree. I will never go deep down. I will not calculate these values again. Rather, I will see in my matrix corresponding to I equal to 1, j equal to 1 and sum equal to 5. I have already saved the answer here and this answer is equal to 1. So I will just use this answer. I will not make the function call again and again. So I know that there is already a valid path that I have found, and I can just use the saved answer from the memory. So this will save my time. Now there is just one more thing. When we are storing sum, now the values of sum can be huge. Instead of storing the sum, why don't we store something else? Why don't we store sum mod k? If we store sum mod k, that is also sufficient. Okay, let's take an example. So we have I, j and sum mod k. There are 3 parameters, right? So what we can do is we can store these 3 parameters. So let me take an example. When we made this call, I was 2, j was 2, the sum was equal to 9, k is equal to 3, right? So 9 mod 3 is 0. So I am storing 0 here. Answer is 1, right? Next we come here. I is 2, j is 1, sum is equal to 7. 7 mod 3. 7 mod 3 is equal to 1. Answer is 1. Next we come here. I is 1, j is 1. 5. 5 mod 3 is equal to 2. I store the answer equal to 1. Okay. What is the advantage of this? Advantage of this is next time when I make a call here, right? When I make a call here with I equal to 1, j equal to 1 and sum mod k, sum is equal to 5, let's say here. So 5 mod 3 is equal to 2. So here I can similarly check, already I have stored the answer. I will not make these recursive calls again. Rather I will use the stored answer. Okay. But what is another advantage of this is, suppose I have another path, right? I have another path in this with same ij. Let's say I was equal to 1 and j was equal to 1, and let's say the sum was equal to 23. In that case, what is 23 mod 3? That is also equal to 2. So I need not go and calculate again. Corresponding to I equal to 1, j equal to 1 and remainder equal to 2. I already know that I have an answer already stored. So I can just use the answer from this. So for different sums also, with the same reminder, if I have the reminder same, then anyway I will get the same answer. Okay. So let me take another example to make this logic clear. Okay. Let's say I have a value 3, right? Okay. I am taking another example. Let's say my k is equal to 7. Let's say I have a starting cell 0, 0 and I have another cell in between. It can be anything. Let me call it AB, and let me say I have the ending cell mn. This is my ending cells. Let's say from the start of the matrix to any cell in between. Okay, this is my matrix, right? Let's say from 0, 0 to any cell in between AB, I have the sum equal to 3. And let's say from AB till the end of the matrix, I have the sum equal to, let's say 4. Okay, let me erase this diagram. So what is the remainder? Now if I add these two, I am getting a total sum of 7. Now 7 is a multiple of 7. 7 mod 7 is equal to 0, right? So this is a valid path, right? Okay, I have already got a valid path. Okay, now let me take another example. Let's say I have another path from 0, 0 to AB only in the matrix. Let's say earlier I had taken a path like this. Now let's say I take a path from here. So this is 0, 0 and let's say this cell is AB. So I am taking another path from 0, 0 to AB, but it has a sum of, let's say 17. Okay, so now I need not calculate this function called AB to mn again. What I can do is, I know that 17 mod 7 is also equal to 3, right? So since 17 mod 7 is also equal to 3, the remainder is sufficient to determine that if I take 17 plus 4, this path, right, this is also going to be a multiple of 7. So this path is a valid path, just like this path is a valid path, like, right? Just like 3 plus 4 is 7, 7 is a multiple of 7, that's why it's a valid path. 17 plus 4 is also 7 and it is also a valid path. Why? Because because 17 mod 7 is equal to 3. It is also giving you the same reminder as the earlier reminder. So any path which has a reminder of 3, right? Any path which has a reminder of 3, any such path, if it adds to a reminder of 4, it will give you a valid path, right? Not just 17. If I have another path, let's say from 0, 0 to a comma b, and let's say the sum of that path is 31. 31 mod 7 is also equal to 3, right? So 31 plus 4, which is equal to 35, will also be a valid path. So what I am doing is, I am saving sum mod k as the third parameter instead of saving the sum. Okay, if I save the sum as the third parameter in my matrix, I will have to separately calculate the answers for 3, for 17, for 31, and then I will have to match each of these paths and do all the calculations again. What I can do is I can just keep a note of this reminder. Reminder here is 3, reminder here is 3, reminder here is 3. So if the reminder is 3 and this path has a reminder of 4, then these two paths, if they add up, they will anyway be a valid path, right? And so on. So instead of storing sum as the third parameter, we are storing sum mod k as the third parameter, so that will be very helpful and we can save a lot of time. So whatever are the three parameters which are optimizing, I, j and sum mod k. Okay, these are the three parameters which are optimizing. Now let's see it in code how we are going to do. So I have taken something called mod, okay, and I have to take a dp matrix vector int dp, and it is going to be grid dot size, and here the second parameter is going to be the number of columns that we have, so that is equal to grid of 0 dot size. And the third parameter, now what is the range of sum mod k? What is the range of sum mod k? What is the range of any number mod k? The range of this will be 0 to k minus 1, right? For example, if you take any number mod 3, it can only give reminders 0, 1 and 2, right? So now we know that our k ranges from 1 to 50. So for the safe side, we will keep this as 51 and we will make all the values as minus 1. Okay. Now here we have dp, so we will pass this dp in our parameter. So vector int dp we are passing in our parameter, we will pass it by reference, and we can give this line of code here. If dp of I comma j comma sum mod k not equal to minus 1, return dp of I, j and sum mod k. And also here, before returning this answer, we will save the answer. That's all. Optimization is just two lines of code. So dp of I, j sum mod k is equal to down plus right. But there's one more thing. Since the answers may be very large, we have to do modulo with this number. So we have a number called mod, which is necessary to do modulo with. So let me do modulo with this number before returning our answer. Okay, now let's submit the solution and see if it is working. Now it should not give time limit exceeded. It is giving compilation error because here I forgot to add dp where I make the function calls. Okay, let's run and see again. There's compilation error, expected expression, unnecessary expression given at the end. Let's compile and see. Expected modulo here. Let's run and see again. Finally finished. Let's submit and see. It is accepted. Thank you for being patient and listening.